Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 3-3 Part 2 homework on solving quadratic equations by completing the square, some real-life applications of that, and converting standard form into vertex form. For this problem, we're just trying to solve this equation by completing the square. Before we can do that, we're actually going to need to distribute out this 4w. So if we do that, we've got 4w squared minus 12w equals 24. And then it would probably be a good idea to divide everything by 4 so we can have just an a value of 1 there. So that would be w squared minus 3w equals 6. And we've already got the constant cleared out to the other side, so we can start the process of completing the square with this left side. So to start that, we're going to take half of the b value, which is negative 3. We're going to square that and add that to both sides. So that's going to be negative 3 halves squared added to both sides. That allows us to factor the left side into w minus 3 halves, quantity squared. And on the right side, we've got 6 plus, now we'll simplify this to 9 over 4. Now 6 plus 9 over 4 is like 24 fourths plus 9 fourths if we get a common denominator. So that comes out to 33 over 4. And we're going to square root that along with the stuff on the left side. So square rooting both sides, we've got w minus 2, or w minus 3 over 2 rather, and then plus or minus square root of 33 over 4. Let's simplify this 33 over 4 a little bit, and then we'll do our final step. So because we have a fraction inside that radical, we need to split that up. And the 33 can stay the way it is. The square root of 4, we can just actually square root that to get a 2. So we've got radical 33 over 2. Moving this 3 over 2 over to the right side to get w by itself, we have w equals 3 plus or minus the square root of 33 all over 2. We just kind of lucked out here and had a common denominator, so hey, why not move it all into one big fraction? For the next few problems, they want us to write the quadratic in vertex form and then identify the vertex. So vertex form, just to remember, that's a times x minus h squared plus k, that formula. So to start this process, we're going to take the x squared plus b part of this right side and essentially focus on that. I'm going to write a parentheses around it initially. That doesn't really do anything in particular, but it gets me to focus on it. What I am going to do is inside this parentheses, I am going to add whatever completes the square for this thing. So taking half of my b value, half of 12, that gives me 6. I'm going to square 6 and add that in here and also on the left side. Gets a plus 6 squared. So on the left side, we can simplify that to g of x plus 36. That's fine. On the right side, I can factor this now into x plus 6 quantity squared. And we still have that 37 hanging around. All we have to do now is get g by itself by subtracting 36. So we have g of x equals x plus 6 squared plus 1. And the last piece of this, they wanted us to identify the vertex. So remember, it's going to be h comma k, and the formula is written as x minus h, so it's actually the opposite of what you see in here for the x value. So we end up then with negative 6 comma positive 1 for the vertex. For this problem, we're trying to write this in vertex form and then identify the vertex. Now this one is a little bit tricky because we have negative x squared plus 6. So when I group the x squared and the x part like I did on the previous problem, I actually need to factor out a negative 1 so that I have only x squared plus or minus whatever inside. So factoring a negative 1 out of that, that leaves me with a positive x squared minus 6x. And then that 16 is unaffected. So I'm going to complete the square now. Taking half of my b value in here, which is half of negative 6 is negative 3, I'm going to square that and add that to both sides. But now I'm going to be careful here. So on the right side, I'm going to add negative 3 squared inside the parentheses. When I add this over to the left side, though, Keep in mind, when you put this negative 3 squared inside this parentheses, it is being affected by this negative 1 outside. So when I add this over to the left side, I actually have to add negative parentheses negative 3 squared. So I've got a negative 1 getting multiplied by that. Because of this negative outside, it has to be the same actual value. All right, so on the left side, this is going to be y minus 9. And on the right side, we've got a negative and then x minus 3 quantity squared minus 16. And then one more step, I'll just add this 9 over here. That gives me negative x minus 3 squared minus 7. Now for the vertex, that's going to be a 3 because of the minus 3 in here, comma, negative 7. This next problem is a big ball of fun. Let's get started putting this in vertex form. To start this process, I need to group the x squared and the x term over in this side of the equation. But when I do that, I want 1x squared inside to make it easier to complete the square. So I actually have to factor this 5 out of these first two terms. So I'll take out a 5, and that'll leave me with an x squared plus 5x inside parentheses, and then I'll keep that 32 over there. Now completing the square here, I have to take half of my b value, half of 5. So I've got 5 over 2 squared that I'm going to be adding in there to complete the square. I also have to add this value over on the left side, but when I do that, this 5 outside the parentheses is actually getting multiplied by the stuff that I just added. So what I have to add on the left side is 5 times 5 halves squared. And if I simplify that a bit, let's see, this would be 5 times 25 over 2. So that would be 125 over, actually it would be 125 over 4, right? Because 2 squared is 4. 125 over 4. And on the right side, we have 5 parentheses x plus 5 over 2, quantity squared, plus 32. One more step to get things, to get g of x by itself. I just have to subtract this 125 over 4. So this is a little bit tricky. So 32, what is 32 in terms of 4? 4 times 32, what is that? That's 128. So I have 128 fourths minus 125 fourths. That'll give us 3 fourths, which actually isn't that horrible. Now to get the vertex, I've got, because of this plus 5 over 2 in here, that means my vertex has an x value of negative 5 over 2. It's opposite of what it looks like inside. And then we have comma positive 3 fourths. So that'll be our vertex. On this problem, the height, y, in feet of a baseball, t seconds after it's hit, is modeled by this h function. This is a pretty standard function. This minus 16t squared is actually a thing. That's due to the effects of gravity. This 96 is the initial velocity that the baseball gets hit up at, and this 3 was the height it was hit from, just in case you were curious. Anyway, they want us to find the maximum height of the ball. Since we are in standard form, and since the maximum can be found at the vertex, it's the y value of the vertex, we're going to use our vertex formula to get the vertex out of this standard form. So we're going to go with negative b over 2a. That's going to be the t value of my vertex. So I'll call that tv, t of the vertex, equals negative b over 2a. So that's negative 96 over 2 times negative 16. And let's see, I'm just gonna take out Desmos and start crunching some numbers. I could probably do it without Desmos, but I'm going to be using it later anyway. So we have negative 96 divided by 2 times negative 16. 3, very good. Definitely didn't need Desmos, but whatever. So 3, in real life, this is corresponding to the number of seconds after which the ball has achieved its maximum height. To figure out the actual maximum height, I just have to plug this back into the h function for t. So if I do that, plugging t in for all of that, let me go ahead and do that on the calculator. So we got 16 and 3 squared, and then 96 times 3, and then finally a 3. So that gives us a maximum height of 100 43, and that's going to be in feet. For this second part of the problem, they want to know how long the ball takes to hit the ground. So it took 3 seconds for the ball to reach its maximum height. So we might think it takes 3 seconds for it to go back down to the ground, but we have to be a little bit careful here because the ball did not start on the ground. It actually started, it's kind of hard to tell, but this 3 again means it started 3 feet above the ground when it was launched into the air by getting hit by the bat. So it's going to be close to 6, but won't be exact. Let's dig a little deeper here. So we need to figure out at what t value h reaches a value of 0. So we're going to set this equal to 0, plug in 0 for h. And now we're going to solve this. Assuming we don't just graph this on Desmos and kind of cheat and get the answer that way, we're going to use a little completing the square just to get some use out of that tool. So to complete the square on this, we need to first clear out this 3, move it to the other side. We also need to divide by this negative 16 so that we only have 1t squared. Makes it a lot easier to complete the square when you have that. So dividing everything by negative 16, we have t squared minus, this will be 6t, equals, this will be a positive 3 over 16 over there. Now I'm going to complete the square for the left side. Half of my b value, half of negative 6, is negative 3. So I'm squaring that and adding that to both sides. That allows me to factor the left side into t minus 3 squared. And on the right side, this is just plus 9 over here. So when I square root both sides, I've got a t minus 3 on the left side. And on the right side, I have plus or minus square root of whatever 3/16 plus 9 is. Now, I am going to be using Desmos later on, so I'm at least going to use the scientific calculator piece of this. And let's clear all this out. So we've got 3/16 plus 9. And I'd kind of like to get that in fraction form. Oh yeah, there we go, 147 over 16. There we go. So we got plus or minus 147 over 16. And I'm going to add 3 to that. So there we go. 3 plus square root of 147 over 16, whatever that is going to be one of our answers. Of course, if somebody asks how long it takes something to happen, and if you give them this answer, they're probably just going to look at you with a blank expression like, what does that even mean? So let's go back to the calculator and actually plug that in. So 3 plus SQRT, square root of 147 over 16, and that comes out to about 6.03. And in case we were curious, because there was a plus and minus square root, 3 minus all that comes out to negative 0.03. So I'm definitely on board with the 6.03 seconds. That seems pretty reasonable. However, this negative 0.03 that I get by doing 3 minus all that, that's not really realistic for this real life problem. So I'm going to discard that. We can't really go back in time. And even if we could, that we would be assuming that the ball was launched off the ground with the same velocity that the bat launched it, which, probably not. If you pick the baseball up, it's going a lot slower to get to that height of 3. Anyway, this is our answer, 6.03 seconds.